Hi everybody, today we're going to look at systems of nonlinear equations. We will also take a look at some systems of inequalities. So some of them will be linear, some of them will be nonlinear, some will be a combination of the two. So to start talking about nonlinear equations, we want to go back and talk about lines. When we were talking about lines, lines intersect at a single point as long as they intersect. But when we have nonlinear equations, we could have multiple intersection points, and it really is dependent on the kinds of nonlinear equations that we have. We still get to use our two methods of substitution and addition to find the intersection points. So it won't be a completely new process, it's just the number of answers we're going to get isn't going to be the same every time. So let's start with the substitution method. I have x plus y equals 7, and I have x squared plus y squared equals 25. So I have one line, x plus y is 7, but I also have a circle, x squared plus y squared is 25. To start the substitution method, I want to either solve for x or y, and the x plus y is 7, and just kind of out of habit, I'm going to do y equals negative x plus 7. I think we have a tendency to solve for y, so that's what I want to show you. So I'm going to plug that into my second equation. So I have x squared plus y squared. Well, y is negative x plus 7. Don't forget to square it, and that's 25. So this is x squared. Remember, when you square a binomial, you get a trinomial. We have this little shortcut. A plus b squared is a squared plus 2ab plus b squared. So I'm going to use that shortcut. So negative x squared is x squared. If I do negative x times 7 times 2, that's negative 14x, and then 7 squared is 49, and that comes out to be 25. X squared and x squared is 2x squared. I have minus 14x, and then I'm going to bring the 25 over, so 49 minus 25 will be a positive 24. Set that equal to 0. I have this coefficient of x squared that's 2, and I know we don't like that, but good news, I can divide it out. I can take 2 out of the 2x squared. I could divide negative 14x by 2, 24 by 2, and 0 by 2. So I come up with x squared minus 7x plus 12 is equal to 0. That looks better. I can think of factors of 12 that give me negative 7. That'll be x minus 3 and x minus 4. So x will be 3 and x will be 4. So we have part of the answer. Remember, we want points. So let's start off with just x is equal to 3. Then y is going to be negative 3 plus 7, which is 4. So here's 1 point, 3, 4. Our other time, x is equal to 4. Y is negative 4 plus 7, which is equal to 3. So I got this point, 4, 3. Let's try a different shape. This time I have x equals 2y and y equals x squared. So x equals 2y is still a line, and y equals x squared would be a parabola. So we have that thing of we don't know how many solutions we're going to have until we do the work. Now this time it already says x equals 2y, so I'm just going to go directly into that y is equal to x squared, but x is equal to 2y, so I'm going to write 2y squared. So this says y is equal to 4y squared. And I'm going to bring this y over, so I'm going to have 0 is 4y squared minus y. I can factor out a y, so I have y times 4y minus 1. So I could set y equals 0. I set 4y minus 1 equal to 0. The y equals 0 is good. 4y then is 1, and y is 1 over 4. So potentially, again, two solutions. So let's go back to our substitution where we said x is equal to 2y. So when y equals 0, x will be equal to 2 times 0, which is 0. So there's 1.00. For our second one, we have y is equal to 1/4. So x will be equal to 2 times 1/4. So x is going to be 1/2. Make sure you write the 1/2 first because it's your x coordinate, then you write the y. So our second method we could talk about is the addition method. And like before, we know we're just going to add, and my first example is pretty easy. X squared plus y squared is 10, x squared minus y squared is 8. X squared plus y squared is, again, a circle. X squared minus y squared is something called a hyperbola, which is kind of like beyond what we've been talking about, so I'm not even going to worry about what it looks like. We're just going to go ahead and answer it. I'm going to add these together. X squared and x squared is 2x squared. Y squared minus y squared cancels. 10 and 8 is 18. Divide by 2, I get 9. Take the square root. X is plus or minus 3. Two values. So let's go back and say, okay, if x is equal to positive 3, then 3 squared plus y squared is 10. Well, 3 squared is 9, plus y squared is 10. So y squared is 1, which says y is plus or minus 1. So this gives me 2 solutions already. I have the 0.31, I have the 0.3 negative 1. Let's repeat that for x is negative 3. I get negative 3 squared plus y squared is 10. Again, gives me 9 plus y squared is 10. So we know that when y squared is 1, we're going to get plus or minus 1. So I have negative 3, positive 1. I have negative 3, negative 1. I got 4 solutions this time. Well, let's look at another one of those. This time I have y squared minus x squared is 8. I have 2x squared plus 5y squared is 12. And we're thinking addition method, but this time if I just add them together, nothing's going to cancel out. So I'm going to do a little rewriting. I'm going to make this negative x squared plus y squared is 8. And then I'll keep the 2x squared plus 5y squared is 12. And because it's the easiest thing to do, I'm just going to take the first equation and multiply it by 2. So I have negative 2x squared plus positive 2y squared is 16, followed by 2x squared plus 5y squared is 12. We add those together, the x squareds cancel. 2y squared and 5y squared is 7y squared. That's equal to 28. Dividing by 7, we get 4 for our y squared. So the square root says y is plus or minus 2. Now, like always, you can pick where you want to plug it back in. I'm going to plug it into y squared minus x squared is 8. So I'm going to start with y is positive 2. And it says I have 2 squared minus x squared is 8. 2 squared is 4 minus x squared is 8. Says that negative x squared is positive 4, or x squared is negative 4. Now, here's a problem. That doesn't work. When I take the square root, it got a complex answer, and that's not what we're looking for here. So this is not going to work. If I plugged in the negative 2, I would have negative 2 squared minus x squared is 8. And again, I would run into the same problem, that 4 minus x squared is 8. And that negative x squared is 4, so x squared is negative 4, and that doesn't work either. So what this says to us this time is I don't have a solution. And that doesn't mean that they're parallel, it just means they never touch. So let's look at a picture of it. I think that might help. So I'm going to go to Desmos just to show you what this looks like. So I have y squared minus x squared is 8. This is that hyperbola we talked about earlier. And then this is 2x squared plus 5y squared is 12. And this is called an ellipse. It's kind of like a circle, but think a little more oval in shape. And you can see these don't touch. So not parallel at all, right? They just don't happen to intersect. So that's always something that could happen when we have these systems of nonlinear equations. So of course we should do some more practice. So this time I said, let's just pick whatever method we want. I'm not going to tell you what to do. So this starts with x squared minus y is 4. And x plus y is 2, and I think you should look at it and think like, what looks easiest? Does it look easiest to substitute, or does it look easy to add them? And I'm really hoping you say it looks easy to add them, because if I add down x squared and x is x squared plus x. Negative y and y, that cancels. 4 plus 2 is 6, so I have this nice quadratic. X squared plus x equals 6. I'm going to turn that into x squared plus x minus 6 is 0. So I think about factors of 6, that will give me 1, and I know that that would be 3 and 2. 3 will be positive, 1 is negative, so x is negative 3, and then x is 2. We have this nice little line, x plus y equals 2, so that's where I'm going to put my value in. So I'm going to say negative 3 plus y is 2. Y would be positive 5, so I have negative 3, positive 5. And then I also have that 2 plus y is 2, which says y is 0. So I have the point 2, 0. So 2 intersection points for this quadratic with a line. So let's try this next one. I have 2x cubed minus x squared is y, and I have x squared minus y equals 0. So I'm going to do substitution, and here's how I'm going to do it. In the second equation, x squared minus y equals 0 says x squared equals y. So I'm going to go back up to this 2x cubed minus x squared and say that's equal to x squared. Let's put all the x squareds together. So I have 2x cubed minus 2x squared is 0. I'm going to factor out a 2x. And actually, we can factor out 2x squared, which leaves us with x minus 1. So the 2x squared equals 0. It says x is 0. And then x minus 1 is 0. It says x is 1. Now we know that x squared is y. So 0 squared is y. It says I have the point 0, 0. And then 1 squared is y, says I have the point 1, 1. So 2 solutions to this set of equations. So let's try this one. I have y as x squared plus 5. I have y as negative x squared plus 9. Hopefully, see if you add it, you get 2y is 14. So the x squared minus x squared cancels. This says y is equal to 7. Now I can plug that back into either one. So let's say we do the top one. I have 7 is equal to x squared plus 5. That says 2 is equal to x squared. So x, when I take the square root, I'm going to get plus or minus the square root of 2. I want to write my answers as the square root of 2 was 7, and the negative square root of 2 was 7. Let's try one more. I have negative x squared plus y equals 2, and I have negative 4x plus y equals negative 1. Again, I think I have this y that's the same power in both, so maybe I can just eliminate that. So what I'm going to do is think about taking the second equation and multiply it by negative 1. So I'll keep my negative x squared plus y is 2, but now I'm going to have positive 4x minus y is positive 1. So I wanted to make these signs cancel out. I have negative x squared plus 4x equals 3. So let's call that negative x squared plus 4x minus 3 equals 0. I do not like this negative at the front, so I'm going to divide everything by negative 1. I have x squared minus 4x plus 3 is 0. And that works out really nice because now I have factors of x minus 1 and x minus 3, which gives me x is positive 1, x is positive 3. So now I need to go back and plug that in. So I have negative 1 squared plus y equals 2. Well, negative 1 squared is negative 1 plus y equals 2, says y is 3. So that was the point 1, 3. Then again, let's do negative 3 squared plus y is 2. Negative 9 plus y is 2, says y equals 11. So my second point is 3, 11. Don't let this negative outside of the squared fool you. Remember, you always do exponents before signs. So we're squaring it and then we make it negative. So now that we looked at some systems of nonlinear equations, we want to talk about some inequalities. Systems of equations have a finite number of solutions. So we might have got 1, 2, 3, 4, or maybe even 0, but we have this countable number. When we're graphing inequalities, we have infinitely many solutions. So to show the answers, we need to graph, and we are going to shade in this solution set. I want you to pay attention to whether you're given greater than or less than, and see how that's strict, just greater than, just less than, not equal to. You want to use a dashed line on your graph to show that this is not equal to. If you do have greater than or equal to or less than or equal to, you'll use a solid line. So a little difference between those two. And let's just use some examples to get through that. So we're going to start with something really simple. X is greater than or equal to 2. So really you kind of start with like x equals 2. And you're thinking this is a vertical line. So it's going up and down. And greater than is on the right. So we want to shade everything to the right. So shading shows where the answer is. So I just shade like this when I'm having to use paper. Let's try y is less than 1/3 of x plus 2. So a line, it has an intercept at 2, and that's a y-intercept, and a slope of 1/3. So I go up 1 over 1, 2, 3. Because it is strictly less than, I want to dash the line. So I don't want to include the points that are actually on the line. And then what you need to do is say, well, where should I shade? Is it above or below? In this particular case where it says y is less than 1/3 of x plus 2, I think less than is below, so I would shade underneath. Sometimes that can get tricky because our problems are going to get harder. So a lot of times you will see books or people talk about using a test point. So I took off my shading to show you how you do with a test point. So in a test point, what you do is you pick a point, and a lot of times we pick the origin because the origin is kind of an easy point to deal with. And what we're going to do is we're going to plug that point into this inequality and see if it's true. So I'm going to plug in 0 is less than 1/3 times 0 plus 2. So I took that point 0, 0, I plugged it into y is less than 1/3 of x plus 2. This says 0 is less than 2. That is true. So that true part says I want 0, 0 to be a part of my solution. So when I go to shade, I want to shade the part of the graph that includes that 0, 0. So you have multiple ways to do this. I, a lot of times, think if it's solved for y, I can just go, oh, is it up or down? Less than is down, so go underneath the line. So the next one says y is greater than or equal to x squared minus 4. This time I have a parabola, and I know the vertex is at 0, -4. And then it opens up, so I'm going to graph like a point to the right and a point to the left. And kind of draw the graph for you. Okay. So again, this time it says y is greater than. So if I was standing at this vertex and thinking where is greater than is up. So it would be everything above the parabola. Again, you could have picked the point 0, 0 and says 0 is greater than or equal to 0 squared minus 4, which says 0 is greater than or equal to -4, which is true. And you would say that's where I'm going to shade is where 0, 0 is. When we have multiple inequalities, we're going to need to shade the region that satisfies all of the inequalities in the given system. It's going to be helpful to use that test point again when we're going to graph. So let's kind of put together what we had. I had x squared minus 4, and it was y is greater than or equal to. And then I'm going to add on y is less than 3. So let's graph both of those. So x squared minus 4, again down at 4, and then 1 to the right, 1 to the left. Let me make sure you can see it. So let's go this big curve. Not shading yet. The second one says y is less than 3. Notice it's just less than, so I want to dash this. So this can get a little bit harder when you're having to shade multiple things, so I'll show you a couple different ways you can do it. So one way would be go back to that test point, like the 0, 0. And you could make sure that that 0, 0 satisfies both of your inequalities. So 0 greater than or equal to 4, true. 0 less than 3, also true. So you would want to pick to shade the region that includes 0. This can be tricky because there are a lot of regions. I could be here, I could be over here, I could be up here. So I really would have to kind of check around. Here's what I kind of like to think about. If I'm looking at y greater than or equal to x squared minus 4, I know that I am above the parabola, so I know I have to be inside of it. And then when I look at y being less than 3, I know I need to be under that line. So I kind of look where I'm double checked. I have a check mark here, which is also a check mark here, which says all of this, I'm sorry, I'm scribbling. This is what we're trapping by those two inequalities. So let's try another one. I have y is less than 2x plus 2, and I have y is greater than 1/4 of x minus 2. So y less than 2x plus 2, I'm going to start at 2. I'm going to go up 2 and over 1. I notice it's a strict inequality, so I dash this line. Greater than 1/4 of x minus 2, I'm going to start down at -2. I'm going to go up 1, over 1, 2, 3, 4. Here's my other point. And then this time, I'm also dashing because it's a strict inequality. So let me do that check mark thing for you again. This first one is my y is less than 2x plus 2. And less than would be below. So I'm just going to kind of check a little bit to say this is below. The second one says y is greater than 1/4 of x minus 2. So that would be above. So this is above, this is above. And I'm looking, where do I see double check marks? And it's in here. So this region kind of looks a little bit like a triangle. It would keep going, of course. that would be my answer. Now this is not super pretty to me. I know that doing this by hand never looks great. It's nice to be able to know how to do both because you never know what's going to be expected of you. You may have classes where everything is online and other classes where you're in class, and so in class you may not have the same technology you have when we're online, but I do want to show you the technology and see how this works. Let's do technology a couple times. I have 2 this time. So I have x is greater than or equal to -6, solid line, vertical through -6, greater than is on the right. And then y less than 6. This time it's a dashed line. I go to 6 and I make a horizontal line, and then under goes here. This part where it kind of turned pink, I had a purple and an orange and it turns kind of pinky is the overlap. That's our answer. So same thing here. I have y minus 1/4 of x is less than or equal to -1. Now, when you're doing the homework, I would say put this in slope-intercept form. So I would have y is less than or equal to 1/4 of x minus 1. I would have a solid line. I would start at -1. I would go up 1 and over 1, 2, 3, 4, put my other point, and then y is less than, so I would shade below. Same thing when I get to a parabola, x squared plus 2. It is a solid line, so I pick the solid. I start at 2. This opens up, so don't be deceived by the parabola being shaped down, and the preview is this one's going up. And then y is less than, so I'm going to click outside. Let's get to this one that we just did earlier where we said y is less than 2x plus 2 and y is greater than -1/4 of x minus 2. So the first one is a dashed line, 2x plus 2, here's 2, up 2, over 1, less than is under. Then repeat it. I'm going to click on the dashed line again. This time I start at -2. My slope is -1/4, so down 1 and over 1, 2, 3, 4. Then it's greater than, so I'm going to click up. And remember, I called it kind of a triangular looking shape, but we can see this is where it overlaps, and you can always check it. So the last thing I want to do is go backwards. I want to give you a graph and say, can you tell me what was graphed here? And it's a system of inequalities. So immediately I think you see that we have a parabola and then we have a line. So when I look at the parabola, I can see the vertex is right here at 0, -5. So this is y, and then I have x squared plus 5 because the h is 0, so it didn't move right or left. Notice that it's shaded above, so I'm going to say this is greater than or equal to, and the equal part comes from it being a solid line. The second thing I have is a line, and hopefully you can see it has a y-intercept here at 3, so it looks like at 4, it's at the point 11, so 4, 11. It also looks like it's at -2, -1, so I'm going to come up with that equation of that line, and then I'll turn it into an inequality. So since I know the intercept is equal to 3, the only thing I really need is the slope. So let's do the slope as the change in y over the change in x. I have 11 minus -1 over 4 minus -2. 11 minus -1 gives me positive 12. 4 minus -2 gives me 6, which says I have a slope of 2. So my equation is y. It's going to be less than, because it's underneath, my slope was 2 times x plus 3. So here's my system. One more thing I wanted to show you is if you wanted to ever draw a picture that looks like this and not have to shade it by hand, and if you didn't have it in the homework, what would we do? So there are 2 choices I like to show you. So I'm going to start in Desmos, where I have y is less than 2x plus 2, the one we just graphed, and also y is greater than -1/4 of x minus 2. So you can see Desmos kind of does that same kind of process of it shades each one of the inequalities a particular color and then shows this deeper color as the intersection. If you don't like the colors, you click on the settings, and then you can change the colors to show the way you want them to. A second graphing calculator I really like is called Geogebra, and I'm just going to graph the same thing and show you the slight difference I see when I put it in here. So I had y is less than 2x plus 2. I had y is greater than negative 1/4 of x minus 2. And at first, looks completely the same as what we did in Desmos, but there's this other part that's different. It gave a letter to each of the inequalities. So if I type A, and then I do the and sign twice, and I put in B, I can turn off the A and the B to get rid of the shading that was individual and only get in the answer for the doubled up part, the and. So I kind of like that when I want to hone in on something and only have one piece, not two, is I can use GeoGebra to do that in a really nice way. So I hope that's really helpful. I hope you find these kind of easy. It kind of goes through a lot of stuff we've been doing in the last week or so. Good luck.